Grade 12 learners. Welcome to today's technical science lesson. My name is Mashud Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. You may send us your questions on 063-629-3655. That's a WhatsApp number. You can send all your questions. We'll be able to respond. As I introduced myself already, let's go to it. Today we're going to focus on the revision. We're going to focus on revision of paper 2. Remember, you are preparing now for your prelim exams. So now we are saying, don't stress. We're here to take you through to say this is what you must expect. So remember, paper 2, you have metal materials, which is 47 marks. Our method and materials, remember, is naming of organic molecules in question 2, including the isomers. And then we are having in question 3 physical properties. That is your melting point, boiling point, vapor pressure, and viscosity. Then in question 4, you have reactions of organic molecules, and then as well as electronic properties of matter. Remember, we're talking here about your doping, so it's part of matter and materials. So that is 47 marks. Then 28 marks will come from chemical change. Your chemical change here, we're talking about galvanic cell and electrolytic cell, with electrolytic cell in question 5 and galvanic cell in question 6. So that is what we're expecting come the 28th of this month when you write second paper of technical sciences. As I indicated, you'll write for 1.5 hours. Try to spread your time well so that you are able to finish your paper. Last year in 2021, so I'm going to focus here on taking you through the entire paper of 2021 so that you are able now to see what to expect and which mistakes you are not supposed to make. So I hope you will go with me. So in question 1, you are going to be dealing with multiple choice questions. We had 5 questions, multiple choice, which is 10 marks. So learners performed at 52% on average nationally on question 1, which is multiple choice questions. Question 2, 45%, as I indicated, that is naming of organic molecules as well as isomers. So that is 45%. And then 37% on question 3, which is physical properties. We do only 4 physical properties, as I indicated: your melting point, your boiling point, your vapor pressure, and viscosity. In question 4, we're talking about reactions of organic molecules. Remember, we're doing substitution, we're doing addition, we're doing combustion. So that must be your main focus as far as reactions are concerned. Look at the performance there. It was 27%. So we'll go through these questions that these learners performed like this so that we rectify whatever happened, more especially in question 4. Look at question 5 there. We're at 31%. So 31% performance nationally in question 5. Remember, we said that is electrolytic cell. And then galvanic cell, it was 29%. And then the total average was at 36%. So we are looking at, during these prelim exams that we are preparing for, we're looking forward for you to be able to prepare and get better marks. Now, as I indicated on the structure of the paper, we had 10 marks. That was 5 multiple choice questions. And you can spend around about, for each 1 mark, you can spend around 1 minute, 1.2 minutes. And then you know that you have about 12 minutes that you can spend on multiple choice questions if there are 5 questions. And then you are able to do that. Remember, you can expect matching columns as well, or one-word questions on the section A as well. We can include those questions. It's not only multiple choice questions. We can include one word or as well as your matching columns. Now, in section B, we have structured or long questions, which is, it was 65 marks last year in the final exam. So the total is 75 marks. You write for 90 minutes. So we're going to have this session for 90 minutes and go through the entire paper as well. Now, what we are saying for question 1, you are given there various options are provided as possible answers to the following questions. Choose the answer and write the letter A to D. Please write the letter. Don't have to copy the entire answer when you're answering the question. If it's 1.1 is A, you just write A. You don't have to write carboxylic acid, for example. So you write the question number, then you write the alphabet. Now, consider the structural formula of a compound below and identify the type of homologous series. Hoping you'll be having a highlighter so that you highlight the keywords as you are answering questions. You can see the keyword there is that you must identify the type of homologous series. So you are able to check. Remember, we said we are doing only 9 homologous series. So if you check this one, how to identify homologous series, if I may help you here. To say all the homologous series is look at the functional group first to say what is that when I remove from this structure, this will become a hydrocarbon. So if I remove, for example, C double bond O, you can see that this will become a hydrocarbon. So you know that our functional group must be having to do with C double bond O. However, this C double bond O must be attached to a carbon and attached to a hydrogen. So you must know that the C double bond O attached to a hydrogen and a carbon, that must be, and it's not a carboxylic acid because carboxylic acid is a C double bond O and an OH for carboxylic acid. For an aldehyde, it's a C double bond O and a hydrogen. So you are able to choose number B as your answer because you see that this is an aldehyde. So it shows that if you know your functional group, you will be able to identify the homologous series. I hope you see the importance of that as I'm giving you a skill there to say always go and find out what is that when you remove this will become a hydrocarbon. That will give you a clue to say which homologous series. In this case, it's a C double bond O bonded to hydrogen and a carbon. Then you would know that it's an aldehyde. And this question had 2 marks. So spend your time, as I indicated, 1.2 minutes. Make sure that you collect for every 1 mark. This question is 2 marks, so you will spend around 2 minutes for that question so that you ensure that you do everything in order. Let's look at 1.2. 1.2 are saying, study the table below and answer the following questions. So we are given here, what is important when you are dealing with physical properties is that you must know that all the time we will give you the dependent and the independent variable. So your responsibility is to know that we have our dependent variables is what we are measuring. Here in this experiment, we are measuring boiling point. Remember, in terms of tech science, we are saying when you deal with physical properties, you have 4 dependent variables. So all the time, you will know that the melting point, the boiling point, the vapor pressure, and viscosity, those are your dependent variable. What is your independent? Independent is what you are changing during the experiment. So our independent variable in this case will be molecular mass, which is you can see they all belong to the same homologous series. But what is changing in this experiment? You can see methane has 1 carbon, ethane has 2 carbons, propane has 3 carbons, and butane has 4 carbons. So you can see that is the chain length. The chain length is increasing. And what is interesting, you will see that when the chain length increases, as we go down from methane to butane, as the chain length increases, look at the relationship there to say as the chain length increases, the chain length increases from methane to butane, what is happening? So I'm saying, you will say here we're dealing with the chain length. Then you will say we're dealing with the chain length as your independent variable. So as the chain length increases, what is happening to the boiling point? You can see the boiling point is increasing. This is very important for you learners to know that a bigger negative number is the smallest number. So minus 164 degrees Celsius will be the smallest boiling point, and minus 0.5 will be the highest boiling point. So you can see that as the chain length increase, the boiling point increase. So they have that relationship. As the chain length increase, the boiling point increase. Now the question is not about boiling point; it's about vapor pressure. Remember, the relationship is that as the strength of the intermolecular force increase, the vapor pressure decrease. So you have to know that as the chain length increase, as the boiling point increase, the vapor pressure must decrease. So they said which one has the lowest vapor pressure. So it must be the one with the highest strength of intermolecular force, with the longest carbon chain. Because as the carbon chain increase, the strength increase. As the strength increase, the boiling point increase. As boiling point increase, vapor pressure decrease. So you're able to see that, okay? So our option would be butane. Why butane? Because it has the highest strength of intermolecular force. I hope you understand that if we're asking about boiling point, the one with the lowest will have been methane. But because we're asking about vapor pressure, the lowest boiling point means the highest strength of intermolecular force. So you're able to choose D there, and you are able to get your 2 marks. I hope you are following me. As we go now to question 1.3, which one of the following combination is true about the substance that is oxidized? This is very much important, learners, to remember all these terms that we use here during redox reactions, because we are saying during redox reaction, loss of electron is oxidation. Loss of electron is oxidation, and a substance that undergoes oxidation is a reducing agent. A substance that undergoes oxidation, so reducing agent is a what? It's a substance that undergoes oxidation. A substance that undergoes oxidation, we refer to it as reducing agent. And that substance is oxidized. Oxidized means the oxidation number increase. So you have to understand that oxidized means the oxidation number increase. That is oxidized. But the substance that gain electrons, gaining of electron, is reduction. And that substance, we refer to it as oxidizing agent. So don't forget that. That is, the oxidizing agent is a substance that is undergoing reduction. And that substance is reduced, which means the oxidation number must decrease. So in our question, the question is saying which one of the following combination is true about the substance that is oxidized. So we're talking about this one. This substance, in terms of electrons, we're saying it must lose electrons. So you know that here, remember, you are given 4 options. Of the 4 options, 2 we refer to them as disruptors. So they are not answers, they're just there to disrupt you. So your duty is to know that a substance that is oxidized is the one that is losing electrons. So you check loss of electron. So electrons must be lost, which is either B or D, which means option A and C are disruptors. So they cannot be answers. So your answer is either B or C. That's what you do then. So you have 4 options. You remove 2 disruptors. You remain with 2 options. Then you are able to engage the 2. Let's look at this one. So we're saying the electrons, they will be lost. So that is correct for both of those 2. And then the oxidation number. Remember, I said oxidized means increase, which means the oxidation number will increase. So the option that has an increase in oxidation number is that option, which is number D. So when you answer multiple choice, you are 100% that you got the answer correct. So we're saying 1.3 will be D. Why? Because a substance that is oxidized is a substance that loses electrons. It's the substance that undergoes oxidation, and that substance is oxidized, which means the oxidation number increases. I hope we are together. Now, 1.4 is based on an electrolyte. So if we know the definition of an electrolyte, it will simplify this now. So it's saying, the question 1.3 is saying to you, an electrolyte conducts electricity because, so you know that an electrolyte, it conducts electricity. It is a solid. That is option number 1, saying it is a solid. Is an electrolyte a solid? That will be a definite no. It's not a solid. It is molten. Is it molten? No. Remember, we are saying that if we know the definition of an electrolyte, we are saying that an electrolyte is a solution that conducts electricity. It's a solution that conducts electricity through the movement of ions, which is option Roman figure number 3 there, which is in these answers, it will be number C. So we are saying we can use definitions as well to ask you multiple choice questions. So it's good that you know all your definitions so that even when you get definitions on the multiple choice, they become easier. Now let's move to our next option, which is 1.1.5. The last question, multiple choice in 2021, was which of the following is correct about the change of mass of electrodes in galvanic cell. Remember what we are saying. We are saying that loss of electron. I would always refer to this so that I don't want you to forget this, because these mnemonics are going to help you to remember at all times. To say loss of electron is oxidation. That is our reducing agent, and that reducing agent is oxidized. But remember, oxidation, it takes place at the anode. It takes place at the anode. So you have to know that this must be is the anode that loses, that undergoes loss of electron, which is oxidation. And remember, gaining of electrons, we are saying, is reduction. Gaining of electrons is reduction, and that we refer to as an oxidizing agent, which is reduced. So don't forget that. And that happens, the reduction, it takes place at the cathode. So you have to remember at all times. Red cat, remember, red cat stands for reduction takes place at the cathode. And ox, we are saying oxidation takes place at the anode. So you don't forget that. Now, if a substance is going to lose electrons at the anode, remember the anode is the one where loss of electron takes place, which is oxidation. So it's going to lose electrons. So we have to look at the mass to say, if you are losing electrons, is your mass going to remain the same? Definitely no. That substance must decrease. The anode must decrease in mass. So you will definitely know that for the anode, remember this applies to solid metals. Please remember that, because in cases where you don't have a solid losing electrons, like in case of chlorine or hydrogen, you'll definitely know that we are going to use something else. Then the anode itself, the electrode itself, won't decrease in mass. It decreases in mass in galvanic cell if the first condition for decreasing in mass is that it must be solid. The solid can lose, when it loses electrons, it decreases in mass. You will understand that. So we're saying the anode, it will decrease in mass. So we have two options that decrease in mass, is A and B, which means option C and D are disruptors. Don't forget, get rid of disruptors, because you are increasing your chances of, instead of having 25% chances of getting the right answer, now you have 50% chances of getting the correct answer. Now, obviously, if now at the cathode there's going to be gaining of electrons, so when you gain electrons, you see that there will be deposit that will happen on the cathode. So obviously, if you are gaining, you will increase in mass because you are gaining. So you can see that there must be decrease at the anode and increase at the cathode. I hope you have understood that. So when you choose option number A, it's because you are 100% sure that option number A is correct. I hope I was able to help you as far as multiple choice questions are concerned, and practice as many questions as you can. And one thing I want to talk about in multiple choice before I get out of it is that please don't leave multiple choice question unanswered. Ensure that you answer all your multiple choice questions so that at least we know that you will get the marks. Remember, you still have 25% chances of passing multiple choice. So there must be an option that you have. Even if you say, I don't understand the question, you can't leave it blank. You must answer all the multiple choice questions. Now, we move to question 2. As I indicated already, that question 2 now, we are dealing now here with your naming of organic molecules. We are dealing with isomers. So here, there are specific things. The main aim of this lesson today is to ensure that you get strategy. As you go on the 28th to write your prelim exam, you go there armed, knowing that this is the strategy you must use for question 2. So we're saying for question 2, ensure that you use them FH, gem, skin. I'm going to use that. It will help you. It will make sense to you very now. Don't worry. So we are saying immediately when you get this question, analyze this question. Don't run to questions. That's why you see we are showing you the slide is only this table. We didn't show you the questions that follows, because if you rush questions, you will be answering questions from a position of not understanding what the table is all about. So start here on the table. The first thing you will do, you will start with the F there. That F, you are saying, what are the functional groups? I told you to see a functional group, you are simply saying, what's that when I remove from this structure, it will become a hydrocarbon. What is that when I remove, it will become an alkane. When I remove that particular something, then it becomes an alkane. What is that? So if you check the first one, you have only carbon and hydrogen. So you know it's a hydrocarbon. So you'll expect in the question that we can ask you to define a hydrocarbon. Remember, a hydrocarbon, when you look at the structure, you can tell that it's a hydrocarbon. How do you know? Because it's made up of hydrogens and carbons only. Please, when you write the definition, you will say a hydrocarbon is an organic molecule, because these are organic molecules. So it's an organic molecules made up of carbons and hydrogens only. So it's made up of hydrogens and carbons. If you don't say only, we're going to penalize you for that. You won't get your 2 marks. So ensure that if and when we say define a hydrocarbon, you will say it's an organic molecule made up of hydrogens and carbons only. And you can see that this organic molecule is made up of hydrogens and carbons only. I hope you are still with me. Now you check the functional group there to say we only have carbons and hydrogens and single bonds are amongst them. So you will know that this must be an alkane. So you're able to know that this is an alkane. How do you know that there is an alkane? There is maximum number of carbons and hydrogens. There is no hydrogen that has been replaced with something else. So you know that it's an alkane, it's a hydrocarbon, it has a single covalent bond between carbon atoms. So don't forget that. Now let's move to say, what is the general formula of this organic molecule alkane that were given? Remember, general formula for alkanes is CN H2N plus 2. So I'm reminding you now to say, as you prepare for exams, know all the general formula for all the 9 homologous series that we're dealing with. So we are saying that it will be CN H2N plus 2. That will be your general formula. Now, that is the GE there, stand for the general formula. So the next one is the molecular formula. Remember, molecular formula, we're saying how many molecules do you have, how many atoms do we have, how many carbons, how many hydrogens do we have there. So if you check in this structure, we have 1, 2, 3, 4 carbons. So this is a C4. How many hydrogens? Is 3 plus 2 plus 2 plus 3. So if you add correctly, it will give you 10. So that will be 3, 5, 7, 10. So you know that C4H10. So for molecular formula, you are simply showing us how many carbons, how many hydrogens, how many atoms are there in that structure. Now, from there, after molecular formula, you go to structural formula. Definitely, because we gave you the structure, we can ask you in the question to say, draw structural formula. For you to draw structural formula, remember, you must be able to draw all the 4 carbons, and then there are hydrogens now that are attached to that structure. So that is a structural formula. So structural formula, you are showing all the bonds, even all the bonds. You don't leave no bond that is not shown. You must show all the bonds for structural formula. So you are able to draw your structure there with 4 carbons. So that is the structural formula. If now, you see, I included C there for condensed structural formula because this is a previous question paper. And if we don't know condensed structural formula, you might have challenge. So you have to know that a condensed structural formula is a structural formula that is condensed. So what we simply did there is to take this carbon and check how many hydrogens is attached to it. Then it's CH3. You can see that. Then the second carbon is attached to 2 hydrogen. Then we write it as CH2. Then the next one is CH2. The last one is CH3. So know the condensed structural formula because you can see our examiners, they're asking you those questions. So you have to know that. Now, that is condensed. So the one that were given is condensed. The one that I've drawn here is structural. So you have to know formulas. So I say general formula, molecular formula, structural formula, and condensed structural formula. And lastly, second from last is the I. The I there stands for isomers, to say, does this structure have isomers? Remember, immediately when you introduce a branch here, you will now have an isomer. So if I take this CH2, for example, I draw 3 carbons, I take 1 carbon, I put it in carbon number 3. Definitely, we are going to have chain isomers. Remember what are chain isomers? We're saying now they have the same molecular formula, but different chain length. You can see this is a 4 carbon, this is a 3 carbon for the longest carbon chain. So remember how we come across the chain isomers. So we're simply saying that immediately when you bring branches, you are now bringing isomers, which are called chain isomers. So I've shown you that this can have an isomer called with the in carbon number 2 there. Now, lastly, we'll ask you to name this organic molecule. So when you name it, you know it's 4 carbons. Remember, for naming what we said as we are revising, we said remember we said it's MAP BP H bond. Don't forget that. MAP BPH bond. It reminds you that if we have 1 carbon, it's methane. If we have 2 carbons, ethane, 3 carbons, propane, 4 carbons, butane, 5 carbon, pentane, 6 carbon, hexane. And for our study in grade 12, we only do up to 6 carbons. So we don't have to worry about the rest of the carbons. So what we have to know is that it's a MAP BPH. Don't forget the difference between propane and pentane. Pentane comes after. Pent means 5. So don't forget that. Then you will remember that when it's pentane, the other P is for pentane. So you are able to know that, oh, this structure will be butane. We can even ask you to name the chain isomer. Remember, this is the chain isomer now. What you will do, you will number the longest carbon chain. So this will be 1, 2, 3. So the longest carbon chain is 3. You know 3 we said is prop. So you know they are single bonds only. So you will know that this must be propane. So this will be propane because we have 3 carbons in the longest carbon chain. And then we are able now to say, okay, if now in carbon number 2, we have a substituent. So that substituent is a meth because it's only 1 carbon. So this map BPH, it will help you as well to always remember. Remember, if now it's 1 carbon, it's no longer methane as a branch or as a substituent. It's no longer methane, it's now methyl. Methyl, because it's running short of 1 hydrogen. It's no longer methane, it's now methyl. So you will refer to this as 2-methyl, because in carbon number 2 we have a methyl, and the parent chain, the longest carbon chain is 3 carbons and single bonds. So that will be propane. So that will be 2-methyl propane. I hope you're able to look at how you can utilize the strategy of F.H. Jameson to answer the questions. Remember, as indicated, always when you go to number B, you would look for that. When you remove, this becomes a hydrocarbon or an alkane. You can see that. And you know the C double bond O between 2 carbons, that must be an ester. So you're able to know that, oh, the functional group is the ester. So you know it's the ester bond, that one. Then the homologous series must be esters. So this is an ester. You now can even know the general formula for esters. CN, H2N, O2. Don't forget we have 2 oxygens there. So I'm encouraging you as you are revising now to know all the general formulas of the 9 homologous series that we do in Tech Science grade 12. Now, the general formula is CnH2nO2. I already indicated to you that molecular formula, we're saying how many carbons, how many hydrogens. In this case, we have oxygen. So you just go on the counting mission. You say carbons, there are 1, 2, 3. So we have 3 carbons. So you will be able to say this is C3. And then you are able to check how many hydrogens is 1, 2, 3, 4, 5, 6. So for molecular formula, we're simply saying count them. How many are they? How many hydrogens do we have? We have C3H6. Then how many oxygens? We have O2. So you say C3H6O2. So that becomes the molecular formula. And this which is drawn here is a structural formula. Structural formula is given. Then if we ask you, you know already that condensed will have been CH3 following all that in that order, which will have been you will have started with your CH3 there, and then you see that it's followed by the COO and then another CH3. So you're able to see that that is your ester. So I'm hoping that you are following me and we are moving together. The next thing we will always ask you, does this have isomer? Remember, I'm saying to you now, this carboxylic acid, we say on this one cake, so that you remember, you don't forget. You are saying at all times, don't forget, carboxylic acid, they form, their esters are, their isomers are esters. So we call them functional isomer because they have different functional group. So carboxylic acid and esters are functional isomers. Aldehydes and ketones are functional isomers. So don't forget, for functional isomers, we're saying cake. See the order that carboxylic acid goes with esters, aldehydes goes with ketone. So you will be able to say this because now is an ester. It must have a carboxylic acid that will be its functional isomer. So a carboxylic acid with 3 carbons, you will remember that will have been propanoic acid. Propanoic acid. I hope you are still following me. So I'm saying this so that you see that if you are following the strategy of F.H. Jameson, you will be able to answer as many questions as you can. I hope I help you. You can apply this to all these organic molecules. You will be able to answer all the questions. Now, the questions that were asked, as I indicated, it was define the term hydrocarbon as question 2.1. So please don't forget the order. We're saying these are organic molecules that are made up of hydrogens and carbon. Don't forget the word only. They are made up of hydrogens and carbons only. Draw the structural formula of compounds represented by letter C. So you go back there. So structural formula was simply saying show all the bonds. So you're able to write all the carbons, but this time you are showing all the bonds. You can see that this structure has 1, 2, 3, 4 carbons. then chlorine is attached there. Then you are able to show all the hydrogens. Remember, in structural formula, you must show all the atoms and all the bonds. So you are able to show all the bonds that this is structure. You see, it becomes easier when you are drawing it, looking at it, you are able to simply draw that structure and you collect your marks. So that is what the question they said for C and E. So for E, obviously, if you are writing the structure, you see butan 1-ol. You know but according to this, but is number 4. So you simply know that but is number 4. So that is but, but there is a OH all there in carbon number 1. 1-ol means the OH is in carbon number 1. So when you are drawing your structure for butan 1-ol here, you will draw 4 carbons because it's but. And then 1-ol, it means the OH is in carbon number 1. Show all the bonds, even the bond between the O and the H for your hydroxyl group there, and show all the hydrogens that are attached to the structure. Then you will have got your answer there for 2.2.2. And then I hope you are still moving with me. Now, write down the algebraic name of compound B. We were on it here. Remember the one that is attached to the oxygen and the C double bond O. Let me put it this way to say the structure that is attached to the C double bond O, that is the parent chain. So you must know that how many carbons are here where we have C double bond O. We have 2 carbons. So you know that that must be your, if it's 2 carbon, it's an ethane. You know 2 carbons means ethane. 2 carbons means ethane. If I can write it for you here. Ethane means 2 carbon, and then you, because here we have a double C double bond O, which is our 8, so that will be ethanoate. So you know, but we have 1 CH3 here. So CH3, you know, is methyl. So this will be methyl ethanoate. So you are able to write. Remember, this is methyl ethanoate. So don't forget that. You are able as well to answer that question. Now, write down the homologous series. Remember, homologous series, if I'm to remind you what are the homologous series that we are doing grade 12, it's only 9. It's alkanes, alkenes, and alkynes. So that is the AAA. And then I'm saying haloalkanes, aldehydes, ketones, and esters. So that is 7. Then we have alcohols and carboxylic acid. So they're saying we must give which homologous series that A and B belong. So you see, A already indicated that this must be alkanes because no double bonds and it's hydrocarbons. You know that the hydrocarbons that doesn't have multiple bonds, more than 1 bond between carbon atoms, that must be alkanes. So it's an alkane, that is for number A. Let's look at number B. Number B already we talked about it. We said it's an ester. You see, if you have analyzed the question, it makes it easier for you to go and plug the answer, and you will see you don't waste much of your time. Now, compounds B and D are structural isomers. So they are telling you now that we have structural isomers between compound B and D. Oh, yes. Remember when I was talking about propanoic acid and our ester there, which we said is methyl ethanoate. Remember we said cake. We said cake. We said, remember, the carboxylic acid and esters are functional isomers. So definitely the question would be, what type of isomers are these? Define them and all that. Then you are able to enjoy your question. So they are saying question B and D are structural isomers. It's a statement. And then define structural isomer. Please listen to the question. They say the question didn't say define functional isomer. It says define structural isomer. So you will define structural isomer. Remember, when you are defining isomers, you will always remember that these are organic molecules. These are molecules or compounds. You can just say compounds or you can say molecules. It's fine. Compounds with the same molecular formula. So they have same molecular formula. Forgive me for writing MF for molecular formula, but in the exam, we want you to write molecular formula in full. So compounds with the same molecular formula, but different. The different always go to the structure. It will tell you what is different. The name of the isomer. So this one, but different structural formula. So you're able to say, oh, what is the same? or if you are lazy, you'll just say but different structures. But it's always good to say different structural formula. I hope you are following. So we're saying all isomers, they have the same molecular formula. So when you see an isomer, the first thing you will write is that these are compounds with the same molecular formula. Then you check what type. The type will tell you what type or what is different. What is different here is the structure, is the structural formula. So I hope you have understood that. What type of structural isomer are compounds B and D? Good, we've done that already, so it makes it easier. B and D were here. Said these are because the functional group are not the same. Carboxylic acid, ester here, and carboxylic acid are two different functional groups. So you have to understand that because the functional groups are not the same, then that must be functional isomer. Remember I said what is different? It is what is different here. What is different here is the functional group. These are esters, these are carboxylic acid. I hope you have understood that and you are enjoying the lesson as far as this is concerned. So that was your question 2. It had 13 marks. Remember now already we have covered 23 out of 75 marks. I'm hoping that we are moving together and we have no challenge. Now, as we move now to question 3. Remember, question 3 is physical properties or physical conditions. Now, the physical properties that we do in tech science in grade 12, we said this is the melting point, the boiling point, the vapor pressure, and viscosity. Now, the first thing that you must know when you're asking questions, we'll always start by asking you definition kind of questions. So it's very much important that as you arm yourself now for the exams, you always know all the definitions. And I'm emphasizing, please use exam guideline 2021. That exam guideline is the one that you will get all the definition we want, even the way we want you to define them. So that is the correct exam guideline. I didn't say refer to the textbooks. I said let's refer to the exam guideline, which is the book that will help us in terms of the document that will help us in terms of all the definitions for technical science in grade 12. Now, we must know what is melting point. Remember, melting point, we are saying it is a temperature. It's not a point. I want to emphasize that that is a temperature. Melting point is a temperature. All the time, remind yourself of that. Like melting point of water is 0 degrees Celsius. That's a temperature. So melting point is a temperature at this temperature, it's a temperature at which the solid phase and the liquid phase are at equilibrium. So don't forget that. It's a temperature at which the solid phase and the liquid phase are at equilibrium. Now, what is the boiling point? You see, short definitions. We don't want you to write long definitions from your own understanding. No, let's utilize the documents that you have been given. Now, when it goes to boiling point, you see these points, they are temperatures. The boiling point as well is a temperature. So don't forget that boiling point is a temperature at which the vapor pressure is equals to atmospheric pressure. So you have to understand that when it comes to boiling point, it's a temperature at which, look at how short these definitions are. So these are marks for you to collect. So we're saying boiling point is a temperature at which the vapor pressure is equals to atmospheric pressure. The only thing I will ask, I will say write it in full. Don't write equal sign, rather write boiling point is a temperature at which the vapor pressure is equals to the atmospheric pressure. And then you have the vapor pressure as your other definition. So we are saying now for the vapor pressure, don't forget, we're saying this is a pressure exerted by vapor. It's a pressure exerted by vapor at equilibrium with its liquid. This one, be careful, you must say in a closed system. So the system must be closed. So please don't forget that we're saying the vapor pressure, you just look at the name itself, is a pressure exerted by vapor at equilibrium with its liquid. At equilibrium with its liquid in a closed system. So don't forget that. It must be in a closed system, because when you're talking about vapor pressure, the water is about boiling to boil, or it is boiling already. Because the water starts to vaporize just before it starts boiling. It starts to vaporize, and during boiling it's vaporizing. So when you say vapor pressure, we're saying this is the pressure exerted by vapor at equilibrium with its liquid in a closed system. I hope you will remember. And then viscosity as our last definition as well, to say this is the resistance of liquid to flow, the resistance of liquid to flow. So that is viscosity. You can see, you can pour water and oil, their viscosity is not the same. You will see that the water will flow much faster, but viscosity, when it comes to your oil, it might take long to flow. So the resistance of liquid to flow is viscosity. So I wanted you to know that there are 4 important definitions when you're going to question 3 that you must know at all times, because we'll definitely would like to ask you 1 or 2 of them during your test and exams. Now we are saying now here, don't forget, if you have any question, you can send the question on our WhatsApp number. It's 063-629-3655. Now those are 4 definitions that we talked about. Now if we look here, remember, when you're dealing with question 3, I want you to look at it this way, that here you are dealing with an experiment. So when you deal with question 3, it's an experiment where, remember, in the experiment we have the variables that we are having in our investigation. Here we will have our dependent variable, we will have our independent variable, and we'll have our control variable. Remember, at all times, dependent is the one that we are measuring, and we said our dependent variables are 4 when it comes to question 3. So we have 4 dependent variables, which is melting point, boiling point, vapor pressure, and viscosity. So when you go to a question, when the question is about viscosity, that is your dependent variable, and then those are the 4 dependent variables. Independent variables that we are doing, I will say to you, you can use the if, chain, mob, just to remind yourself of our independent variable. What do we change during this experiment? We either change the intermolecular force, we can change the type of the functional group, we can change the chain length. So let me not be fast so that you move with me. So we're saying our independent variable, it can be the intermolecular force, the functional group, the chain length, the molecular mass, or branches. So some structures are branched. For example, if you look at number A and number B, you can see that the chain length there, the longest carbon chain length is not the same. We have 4 carbons in the longest, 4 carbons, and then here we have 3 carbons in the longest chain that we are having. So you are able to see that, okay, here it means we are referring to chain length. One learner will say this is talking to chain length. Another will say, no, sir, this is talking to branch. Yes, you can see that we have 0 branch here. We have 1 branch there. So you must be able to know when you see when you compare organic molecules, you will see as to what is the same about them and what is different. And what is the same on all of them? They are all hydrocarbons. They are all made up of hydrogens and carbons, and they are made up of hydrogens, carbons only. So the first 2 you can see. But if you go to number C, you are able to see that this is an alcohol. This is an alcohol, and it has 4 carbons. You see now, this question was asked in question 2. You were asked to draw, I will remember, you were asked to draw the structural formula of compound represented by E. E, which is butanone. Look now, if now during exam you are able to have an eye to see, butanone is given here. So the memo to that question was here, just here under your nose. So be able to check all this stuff. Some of stuff you can find that they are responding even to the questions that you asked. So now butanone has been drawn, which was the question that was asked. Let me write the name correctly. Butanone, because we are saying in carbon number 1 we have an OH. So that is butanone. Then in number D, you can see we have a carboxylic acid, because that is a COOH. Some would like to say COO, and they remember that is a carboxylic acid. So you can see that we have all those structures. Now, if we look at the questions that are asked, what type of intermolecular force exists between the molecules of these compounds. So they are asking now questions on A and B. Remember, I want you to remember that, don't forget, when I started, I said we do 9 homologous series, which is alkanes, alkenes, and alkynes. I said we do haloalkanes, aldehyde, ketones, and esters. I said we do alcohols and carboxylic acid. So what we have to remember at all times is that the alkanes, the alkenes, and the alkynes, they have what we refer to as London forces. London forces. And the haloalkane, the Hague, so I say AAA, they have London force. The Hague, which is your haloalkane, aldehyde, ketones, and esters. These ones now, they have London forces and dipole-dipole. So don't forget, these ones, they have dipole-dipole interactions, dipole-dipole forces that we find. So obviously, these ones will have the strength of the intermolecular force found in all these 4 will be greater than this one, because these ones, they only have London forces. So you have to know. And then when you come to AC, which is your alcohol and your carboxylic acid, alcohols, we are saying they have, and carboxylic acid, all of them, they have the London force, dipole-dipole, and they have what is referred to as hydrogen bond. So hence we are saying this is the strongest intermolecular force, because they have hydrogen bond, which is that bond that is hydrogen of one organic molecule to oxygen of another. So I don't want you to make a mistake of saying the bond, the hydrogen bond that we are referring to as the intermolecular force. Remember, intermolecular force is between 2 molecules. It's not within one molecule. So it's the hydrogen of one organic molecule to the oxygen of another molecule. The difference between alcohols and carboxylic acid is that alcohol, they have only one site, which means they can form one intermolecular force. Whereas this one, it will form 2 hydrogens. We say it's a dimer, so it has 2 sides of hydrogen bonds. So the difference, alcohols have one side, so they can form 1 hydrogen bond, whereas the carboxylic acid, because of the 2 oxygens that it has there, is able to form 2 hydrogen bonds. So hence the carboxylic acid are the strongest. So you will always, if you have to compare the carboxylic acid and the alcohol, you will know that the carboxylic acid are the strongest. So in this question, they said, you are given compound A and B. What type of intermolecular force exists between the molecules of these compounds? So you have to know that A and B, if you look at them, they are all hydrocarbons. They are all alkanes. So you will know they have London force. So if you know this, you will be collecting your mark to say they all have London force. Which compound, A or B? Now check the question. You simply have to say A or B. You don't have to explain. You just have to choose there. Which one between A and B has a stronger intermolecular force? So you go to the structure, you say, oh, this one is branched. This one, it has the longest carbon chain. So you can see that the parent chain, this one 0 branch, this one 1 branch. So you are able to see that the structure that is having less branch, it will be having the strength of the intermolecular force will be the highest. So it means the intermolecular force, you must write it in full, because if you write IMF, it will read International Monetary Fund. That's the IMF. So please don't write IMF in the exam. Write intermolecular force. Intermolecular force. Write it in full. So we're saying the intermolecular force of A are stronger than the intermolecular force of B. Why? Because A has no branch. So it's not branched. But B is branched. So as the number of branch increase, the strength of intermolecular force decrease. So you have to understand that here we are referring to branch. You can as well say this is not branch, this other one is branch. The other one will say this one has a longer chain length, this one has a shorter chain length. But in terms of the molecular mass, don't forget the molecular mass would be the same. So I hope you understand now that you can be able to answer that question to say which compound is stronger. You are saying A. Why A? Because it has no branch. It's not branch, or because B is having a branch. And as the number of branch increase, the strength of intermolecular force decrease. So you are able to collect your mark. The boiling point of compound A is compared, sorry for that, is compared to that of compound C. So we are comparing the boiling point of A and C. So what if you look at A, you are having that structure which is a 4-carbon structure of butane, and then we have C, which you said is butan 1-ol. You can see something in common there, something in common there. This is butane, this is butan 1-ol. You will see that something is in common, and the question is saying now, is this a fair comparison? I think you will say it's a fair comparison. Why? Because all the structures, they have 4 carbons. All these homologous series, the two that we are having here, which is an alkane and an alcohol, all the organic molecules given here, they have 4 carbons. So we want to check at the whether what is the effect of the functional group on the intermolecular force. So you are able to say this is a fair test because you are saying they all have 4 carbons in their longest carbon chain. Now, which compound has a higher boiling point? Remember, when it comes to higher boiling point, it means this one. Remember we said hydrogen, this OH, now it will bring about a hydrogen bond. When this hydrogen is bonded to another oxygen of another molecule, we'll have hydrogen bond. So these ones, because of the presence of hydrogen bond, and hydrogen bond is the strongest, then it will have the highest boiling point. We dealt with this question when we're dealing with multiple choice questions. We're able to say if the strength of intermolecular force increases, then the boiling point will be high as well. But the vapor pressure will decrease. So in this case, the boiling point will be higher for C as compared to A. What is the reason? Is the strength of the intermolecular force, because compound C has hydrogen bond. Hope you understand that. Now, and when you are answering these questions, look at question 3.2.3. Be careful not to write long paragraphs, because sometimes we lose meaning when you are writing long paragraphs. Write in point or in bullet form. Just write in bullet form. Usually we'll say use the eyes there to say what is the type of intermolecular force, compare the strength of the intermolecular force, then refer to the energy required to overcome the intermolecular force. So it's important that you look at those 3 things to say, okay, what is the type of intermolecular force, the chain length, compare the strength of the intermolecular force and the energy, compare the energy required to overcome the intermolecular force. So I will refer to that as I. So please make sure that you do that as you explain why compound C has a higher boiling point than compound A, because question 3.2.3 is saying explain why you are saying compound C has a higher boiling point. So you will be able to check to say compound C, I said in bullet form, you'll say, oh, compound C has hydrogen bond. So the first thing, you're identifying the type of intermolecular force. They have hydrogen bond as compared to compound A that has London force. So you'll see the first thing you will tell us about the force that they all have. Now, then you will say to us, you will compare the strength of the intermolecular force to say in C, which has hydrogen bond, is stronger intermolecular force. C has stronger intermolecular force than A. So you're comparing the strength. So that is how you get your second mark for the C there, for comparing. Number the third bullet there, you will refer to the energy to say, since while C has stronger intermolecular force, it means that for C, more energy is required. More energy is required to overcome the intermolecular force. So you must be able to say that more energy is required to overcome the intermolecular force. So you're able to do that. Now, look, that is how your 3 marks will be allocated. So it will be for the intermolecular force, it will be for comparing the strength of intermolecular force, and for the energy. But when we talk about energy, always say energy required to overcome the intermolecular force. Remember, this is your paper, 90 minutes. You must be done with the whole paper. Even ourselves, we must ensure that in these 90 minutes that we are having, we must be able to do the entire paper so that you can see that it's doable. Arrange compounds A, B, C, D according to decrease in vapor pressure. It didn't say according to increase. So that is very much important for you to say in a decreasing order. The vapor pressure must be decreasing. So you must start from the highest to the lowest. So you can see that the one which you have the highest, it means it must have the less strength of intermolecular force, which is your B now. Your B has the least of the strength of intermolecular force, followed by your A. Remember, C is an alcohol. It will come after that, which is your C. Then D will be the lowest. So you will have a B, A, C, D in a decreasing order there. To say you start from the highest to the lowest. So the highest vapor pressure means the lowest boiling point. Don't forget that. You are able to answer. Then you had your 12 marks. Then you rush. You go to the next question now, which is question 4. To say in question 4, it's saying consider the two reactions. Remember, question 4, you are doing now reactions of organic molecules. In these reactions, you are doing substitution, you are doing addition, and you are doing as well combustion. You can call it combustion or you can call it oxidation. It's the same reaction. So now, these are the reactions that you are going to focus on. And as well, sometimes we can even include here esterification. Sometimes we will just bring esters in question 2, where we'll ask you to identify these esters, because you have to know how to identify the esters. Now, we are saying now substitution. Don't forget, we are saying here triple S. That's our strategy to say how will you know that this is a substitution reaction. What you will see is that for substitution, you will have a saturated forming saturated. So the type of reaction is substitution. What is saturated? Saturated is when we don't have no multiple bonds between carbon atoms. It means we don't have a double bond or triple bond, which means the first thing you will look at is that in my reactants, do I have a single bond or double bond? If it's only single bond, you will write S. Then you go to the product. Say in the product or products that are formed, do we have single bonds or double bonds? If you still have single bonds, you say, I have single bonds, only single bonds between carbons. In the reactant, only single bonds between carbons. In the product, that must be substitution. However, be careful not to confuse it when you are dealing with combustion, because I will explain how you will see combustion. Now, when it comes to addition, what you will do is that you will have a reactant that must be unsaturated. So you must have a double bond or a triple bond. In this case, we'll be focusing on the double bond. So when you see a double bond, you know that it's saturated. And the double bond undergoes addition. So for yours is the simplest one, because when you see a double bond, you know the type of reaction will be addition. So it becomes easier for you to see that all I'm looking for is a double bond. If I see a double bond, I know the double bonds will undergo addition reaction. So we say USA. So USA, we're saying you are having unsaturated hydrocarbon, which is a double bond in this case. And then if that forms saturated, so the type of reaction is addition. So we're saying USA triple S. Now the last type of reactions that you are doing is our combustion. For combustion, remember, we are saying here you are having your hydrocarbons or your organic molecule. Hydrocarbons plus oxygen forming carbon dioxide plus water. Don't forget, energy is given off as well. So there are 3 products in real essence that are formed. Is carbon dioxide plus water. This is our oxidation or our combustion. So that will depend on the amount of oxygen. So if we are using excess oxygen, so we'll form carbon dioxide, water, and energy. And for our studies, that's what you must know. So it means immediately when you see hydrocarbon reacting with oxygen, you will know that that is going to undergo oxidation or combustion. Then you are able to say, okay, this is going to form carbon dioxide, water, and energy. Carbon dioxide, water, and energy are formed. So please, these are your reactions. This question was poorly answered, as I indicated, and you can see that this you can collect as many marks as you can. Because let's go to the question. It says, consider the two reactions below and answer the questions that follow. So if you check here, you will see that you are given reaction 1. So if you look at reaction 1, I told you, all you're looking for is a double bond. Do we have double bonds? Do we have single bonds? Do we have triple bonds? If you look at reaction 1, we have a double bond. So you know double bond is unsaturated. So you are able to say this is unsaturated. What is in the product? This is saturated, because saturated means single bonds between carbon atoms, single covalent bonds between carbon atoms. So you see that we have U forming S. In real sense, I told you when I started that immediately when you see a double bond and these are reactions, you must know that it will undergo addition. So we are saying USA. So this must undergo addition. So that is unsaturated will form saturated, which is addition type of reaction. The only question will ask you, the other question that will ask you will say, what type of addition? Because already you said USA, you said unsaturated forming saturated, so we call it addition. Then we'll say what type of addition. Then you check what we are adding there. We're adding hydrogen, hence we'll refer to it as hydrogenation. So we are saying you must know the general type. The general type of reaction we are saying is addition. The specific type of reaction we are saying is hydrogenation. Why do we call it hydrogenation? Because we are adding a hydrogen. And then you can see the two hydrogens are added there on the double bond. Each will go to the two carbons that are having a double bond there. So there are three questions now. We're saying what type of reaction? You said it's addition. What type of addition? Hydrogenation. Why you call it hydrogenation? Because we are adding hydrogen. And then the next question would be, what are the physical conditions? What are the physical conditions? What are the physical conditions now that we need for this reaction to take place? Is there any catalyst that we need? Yes. It's either we'll say platinum. Just write one. It's fine. Unless we say two, but most of the time we'll ask you for you to give us one reaction condition. So the reaction condition will be that this is a platinum catalyst, or palladium, or nickel. You are spoiled for choice. You have three of them. So you can write any of those three. So know that for hydrogenation, we're going to use platinum, palladium, or nickel. So you are going to use platinum, palladium, or nickel. So those are your questions that you are expecting us to ask you. Now let's go to reaction 2. Remember, this was final exam last year. Reaction 2, we are saying, okay, we're given 1, 2, 3 carbons there. Okay, you know 3 is P, is prop, but there's an alcohol, so it's propanol, propan 1-ol, because the OH is in carbon number 1. It's important for us to know where the OH is. So the OH is in carbon number 1. So it's propan 1-ol, and then we're coming with HBr. So remember our strategy. We said, look, is there any double bonds there or triple bonds? The answer is no. So because there's no double bond, this is saturated. Then you go to the products to say, in the products, do we have any double bond or triple bonds? The answer is still no. If there is no double bond, you say this is single. So it's single, single. Single is forming another single. So you know that must be substitution. So it becomes easier for you to identify substitution. So we're saying substitution is formed between when a saturated hydrocarbon, after reacting, it remains saturated. So we refer to the reaction as substitution. Just look at that. Then the next question would be, what type of substitution? So you can check. We're bringing HBr here. But now, for substitution, we only took the Br here. It came and substituted the OH there. You can see where there was OH. In fact, this is in that position, but in real effect, it has substituted the OH there. So the Br is taking the position of the OH. So the Br takes the position of the OH. So you know when we bring Br, it's a halogen, group 17 elements. So we will refer to that as halogenation, because you are substituting with a halogen. So what type of substitution is halogenation? Sometimes you have forgotten that it's substitution. Would I be wrong if I say bromination, because we are using bromine? Then we can allow you to do that. But it's better when you just refer to it as halogenation. Then you will be able to get your marks. So please collect all these marks. So with this SSS USA, you will have got total on this question. Look at the questions that we're asking you now. We're saying reaction 1, write down the name of reaction 1. Already we did. We said, oh, it's addition. So you just say addition. You get a mark. What is reaction 2? Oh, we said it's substitution. You got a mark. And then write down the formula, the following. Always look at the words that are in capital letter. The one that are in capital letter, we're emphasizing there. You see, you can write the name or formula of a catalyst. Oh, we said for reaction 1, we said platinum, PT. So it's allowed. It's allowed. But if the question will say write down the name, you write platinum in full. But because you said or formula, so it means you have an option. So you can write PT, PD, or NI for nickel. Now, one reaction condition for reaction 2. Or reaction 2, you can see this is our substitution. Remember, substitution all the time. Remember this, that when you are dealing with substitution, we use mild heat. We don't use very strong heat. It must be mild. So know that you just say the reaction for reaction 2, you can use mild heat. Then you were able to answer all those questions, and then you move with the question as it goes. It says the product in reaction 1 can react with bromine or oxygen. It can react with bromine or oxygen. Write down a balanced chemical equation for the reaction of propane and bromine. So you can see now that still here we're having propane. Propane, you know, is 3 carbons. So you will draw the structure. It's a hydrocarbon. So it's 3 carbons and the hydrogens there. You must show, because the question says write down a balanced chemical for the reaction using structural. You see, we even make it in capital letters so that you don't make a mistake, because if you're going to write molecular formula or any other formula that we didn't ask, then you will forfeit marks. So always look at that. We're saying structural formula. So you draw your propane as a structural formula, and then you draw it like that. I hope you are enjoying yourself, and then you will do this paper, write it again alone, and see that you are able to do this, and then as you prepare yourself for the final exam. So you can see this is saturated. So saturated, in our case, you know, we're going to substitute. Obviously, we're going to remove 1 hydrogen and put a bromine. Now, the question that comes is, which hydrogen are we going to substitute? This is a nice one to say, now we have this carbon number 1, carbon number 2, carbon number 3. Which hydrogen are we going to substitute? Because we're agreeing that this is substitution. But which hydrogen? Always, you will now substitute from the poorest carbon, which means the carbon that is having the less number of hydrogen. So you can't substitute on the carbon that is having 3 hydrogens. No, the poor in this case will become much poorer, meaning that you will take the hydrogen from the carbon with less number of hydrogen. So meaning that in your product, carbon number 1, because it was having 3, it will remain with 3. But carbon number 2, that was having 2 hydrogens. Now we're going to substitute there with the bromine in carbon number 2. So you are able to do it like that. Then you collect your marks. Just look at the marks. Don't forget the hydrogen that you substitute, this hydrogen that you substitute here, it must now bond to the Br. So know that during substitution is 2 reactants. Those 2 reactants are forming other 2 products. One product we refer to it as an organic molecule. The other one is an inorganic. Remember, inorganic, it has no carbon. Organic has carbon. So don't forget that. So you are able to do that. They said write down a balanced chemical reaction for the reaction of. Then you have 4 marks. You are rich. You have 4 marks, so you can get for writing the structure of propane, for writing. Remember, even the Br2, I didn't write as Br2 because this is structural formula, means you show all the bonds. So I showed you the bond between Br and Br so that you are able to do everything correctly. Then you get the mark for the 2 products. Then you have your 4 marks. Remember, we said you can use mild heat here. You can even just use sunlight. So if you use sunlight as a condition, but in this case, because the condition was not asked, you will do what you are asked. Write down the names of formula of 2 products formed when propane reacts in excess oxygen. Remember, excess oxygen, that must be combustion or oxidation. I told you about the 2 products, that we have carbon dioxide and water. Don't forget that. Write down the name or formula. So always check, because sometimes you can say write down the name. So you must write carbon dioxide as a name and water as a name. So check always what we are asking you. Now, as we move, question 4.4, electronic properties of matter now. Remember we said this is part of matter and material. So expect that you will have these questions that are asked here. A semiconductor is a solid substance that has electrical conductivity between a conductor and an insulator. Now, the conductivity of a semiconductor can be improved by adding an impurity. That's a good thing, because if you are having a semiconductor which is intrinsic semiconductor, which means a pure semiconductor, when you bring it impurities, so you're having something clean. When you bring something that is not pure, then you are doing a process called doping. So the name of the process is called doping. It means we are having a pure semiconductor. We are bringing in impurities, that is to increase the conductivity of that particular semiconductor. Define an intrinsic semiconductor. I define it for you. I said this is a pure semiconductor. So these were 2 marks for you to collect. You have to 2 ways. Pure semiconductor, you are 2 marks richer to answer that question. Distinguish between N-type and P-type. So N from the word negative and P from the word positive. So you have to know that if it's an N-type, it means we have access more of electrons than protons. But it is a P, because remember, electrons are negatively charged. So the N there, it must remind you, is negative type. It means we have some more electrons. And then the P type. So they say distinguish between them. So when you're differentiating between them, you will say the N type, they are formed when, remember our semiconductor. In this case, we can use silicon for that matter, which we said is tetravalent, which means it has 4 electrons in the outermost energy level. So there are 4 electrons. Go again to the groups there, you will find them, that there are 4 electrons in the valence electrons, and then which means they are running short of only 4 electrons to be fully filled. So immediately when you bring more than 4, we bring pentavalent. Penta means 5. So when you bring phosphorus, which has 5 electrons in the outermost energy level, obviously the other electrons will bond here with these ones, but now we'll have extra and excess electron, and you know electrons are negatively charged. So you are saying that the N-type is formed when we doping our pure semiconductor with a pentavalent in that fashion, so that you are able to get that. I hope you have seen. So we're saying we're having a semiconductor. In this case, it's a pure semiconductor. We bring an impurity. In this case, we're saying phosphorus, which is pentavalent, which is carrying 5. So 1 extra oversupply. So we have 1 extra electron, hence it becomes negative because of the extra electron that is negatively charged. The P-type is when you are having same silicon, you can bring shortage, you can bring 1 electron short. So if you bring, for example, boron, which is trivalent, which means it has 3 electrons in the outermost energy level, obviously there will be one that positive hole. There will be 1 positive hole that is not filled there with the electrons. So hence now we'll have the P-type. So you must be able to know the positive type and the negative type. I hope you got that, and we can move. So that is question 4. We are doing fine in terms of time as well. Now, question 5, we are talking here to electrolytic cell. Remember things to remind yourself. When you're dealing with the electrolytic cell, I'm saying to you, before you do anything, remind yourself of this definition. What is electrolytic cell? What is electrolysis? So we're saying this is a cell, this is a process. So electrolytic cell is a cell, electrolysis is a process, but all of them, they convert electrical energy from E. Just look how it starts there. From electrical energy, they convert electrical energy to chemical energy. Please don't forget that. So you must know those 2 definitions, and know the definition of an electrolyte, which is what was asked in the multiple choice when we started. An electrolyte, we said, is the solution that conducts electricity. It's a solution that conducts electricity through the movement of ions. So it's the solution that conducts electricity through the movement of ions. Please don't forget those three definitions. You must know them before you write this kind of cell, electrolytic cell. So for the electrolyte used in the cell above, write down the name of the cation and the anion. So here we want the name. So you remember, cation is a positive ion. So cation is a positive ion, which is copper ions. So that will be copper. It's copper ions here. And then anions is chlorine, the chlorine ion. So you're able to write that. Now, the chloride ion and the chlorine ion and the copper ion. Which electrode represents the following? Remember, we are saying when we are dealing with electrolytic cell, we always starting with the word panic so that you don't forget. Panic is saying the positive is anode. So you must be able to know that, oh, the positive one is the anode, the negative one is the cathode. So you must know that this is the anode because it's positive from the word panic, and then this is the cathode because it's negative. Please, when you're given, just start by identifying which one is the anode, which one is the cathode. Which electrode represents the following? So you have to check now that an anode is the positive one. So this one, the positive one, is our anode. That is the anode, is the positive one. And the cathode one is the negative electrode. So the positive electrode, so that panic is able to give you light in terms of that. Define the term oxidation. We did that when we started to say oxidation is a loss of electron. Loss of electron is oxidation. Write down a balance reaction that occurs at the positive electrode. Remember, positive electrode is the anode, and at the anode we lose electrons. Please don't forget that. We are saying that now that chlorine will in electrolytic cell will always lose electrons, will always be in the anode. So don't forget that. We will have chlorine always losing electrons. So the electrons, as long as we have chlorine, it will be 2Cl minus forming Cl2 plus 2 electrons. So I'm saying always in the electrolytic cell, chlorine will always lose electrons. Please don't forget that. Define the term reducing agent. When we started, I said to you, loss of electron is oxidation. Is a reducing agent, is oxidized. Don't forget, what is a reducing agent? It's a substance that loses electron or a substance that undergoes oxidation. So the only thing that you are adding there is that this is a substance. It's a substance that undergoes oxidation or a substance that loses electrons, and that substance is oxidized. Please know these definitions and collect your marks. Now, question 5. Question 5, I was still doing well in terms of time. You see, you are able to do these questions and answer them within that 90 minutes space. So I'm here to show you that you are able to do that. Now, draw a diagram showing a cell that is used to electroplate a spoon with a silver using a battery. Indicate the name of the electrolyte, the anode and cathode, and the battery. Now, it's very much important, learners, for you to remember that our electrolytic cells were having a beaker, one beaker. Inside that beaker, we are having definitely, this is electroplating. So look at a situation where you are painting something. You are painting maybe metal or something. You want to paint that particular thing. That metal won't be doing anything. All will be happening is that you will have your paint that will be reduced, as that will be decreasing obviously as you are busy painting. So what is happening during electroplating? What we are having? We are having a metal. In this case, they told us that the metal is silver. So we are told that this is Ag. Silver is Ag. So you are having a spoon. I wish I can draw a spoon. Look at my spoon. I've tried my best. So that is a spoon. So it means during electroplating, we are having a metal. We are having a metal and an object. We are having a metal and an object. So what you have to understand is that the metal will always lose electrons. Metal will always lose electrons. And on the, remember the other thing? On the other side, we're just writing the reverse reaction of the. So all you have to do is the reaction of losing electrons by the metal. Then when it goes to the object side, all you have to do is now write the reverse reaction that you wrote on the metal. So there is only one reaction, the reaction that is happening in the metal, which is losing lots of electron, which is oxidation. Now, on the side of the object, you will have the reverse reaction being written. For example, if a metal loses electron to become M++ an electron, this side, on the object, this side, you just write this reaction in a reverse, which is the metal must gain electrons to form the metal. So, which means in this case, I told you that panic, don't forget that panic. So you must know that the side where we are having the anode is the positive one. Positive is the anode. So the bigger one is the anode, and in the anode we lose electrons. So that's where we have the metal. So you must be able to connect your metal to the anode, and then your object, so metal to the anode and object to the cathode. So on the cathode you'll have your spoon there. So don't forget, because we have silver is going to lose electrons this side. And then on the side of the spoon, you are going to gain the electrons. So you just write the reverse reaction of that. So it's only one reaction. Loss of electron where the metal is, and where the object is, you are writing the reverse reaction. Then you are able to get your full marks. Now, in this question, they say we must write the name of the electrolyte. So our electrolyte here would be silver. Silver is oxidation of +1. So it must be silver nitrate, AgNO3. That is the name of the electrolyte. So AgNO3, we answered that. Which one is the anode? Is the metal. Where silver is the anode, this one. So you must be able to show for us that this is the anode. And then which one is the cathode? Is where we have the object. The object is the cathode. So you are able to show that we have the cathode there. And a battery. You have shown our cell here that we have a positive and a negative. Then you collected nicely your 3 marks, and you have 13 marks there. So please revise as many as you can, and then questions as you can, and then we will definitely do well during the time of the exam. Now, our last question is galvanic cell. Unlike electrolytic cell, remember with electrolytic cell, I said it's from E to C. It's from electrical energy to chemical energy. Now, in galvanic cell, we now convert energy from chemical energy to electrical, meaning we're producing electricity now to electrical energy. So this one, when you say define galvanic cell, you'll say it converts. Galvanic cell is a cell that converts chemical energy to electrical energy. Please, that is the definition. You cannot go to the exam room without understanding. Now, let's look at our question. It says, learners performed an experiment to determine the electrode potential of a zinc copper cell, which means they wanted to determine the EMF of this cell. They assembled the apparatus as shown in the diagram below. So we have our nice diagram there. You can see we have a zinc in a zinc sulfate solution. We have a copper in a copper sulfate. We have a salt with a salt bridge with a salt. Our salt is KCl. Remember, chlorine is a group 17 element, which means it has the minus -1, the charge of -1 there. So you will see that when you separate your salt here in the salt bridge, the cation will be K+, and the anion would be the chlorine minus. So you have to know that chlorine is always -1. Then when you add the 2 oxidation number must give you a 0, which means the potassium to have a positive 1. Now, which type of the cell is represented by the diagram? So already we said this one is no longer electrolytic. This one is what? Galvanic. Why? You can see that we are producing electricity here. Chemical energy to electrical energy. So it's galvanic. Write down a balanced equation for the net ionic reaction of the above. Now, this is very much important sorry, for you to understand, to say if you have to write the net ionic reaction, it's easy when you're using the table of standard reduction potential. In this case, I'm referring to table 4b. If you go to table 4b, you will realize that we are having standard reduction potential of zinc as zinc 2 plus 2 electrons forming zinc. We're having the one for copper as copper 2 plus 2 electrons forming copper. So all you have to understand is that with the first reaction, the one with the lowest standard reduction potential, remember the standard reduction potential for the zinc one For the zinc one, if I might write it here so that you follow what I'm talking about. If you check, zinc is negative 0.76, and then for copper 2 plus is positive 0.34 volts. That is the standard reduction potential. So what we have to know is that reduction potential means ability. Reduction means gaining of electrons. So the one with a bigger ability to gain electrons will gain electrons. In this case, you can see that this is positive 0.34, is higher ability to gain electrons. So copper, because it has a higher ability to gain electrons, it won't change. It will remain as copper 2 plus 2 electrons, and then forming copper now with 1 arrow. However, this one, the zinc, because it has a lesser standard reduction potential, it will reverse, meaning we'll write it from zinc going that side, which will be zinc forming zinc 2 plus 2 electrons. So you are able to form that. Please remember at all times, you just look at the standard reduction potential, which is the ability to gain electrons. The one with the bigger ability to gain electrons will gain electrons. The one with the lesser ability will lose electrons. Then immediately when you write the half cells, please make sure that you are showing only 1 arrow there. Not 2 arrows, but one arrow. So you make a line there. Then you first ensure that the electrons are balanced. If the electrons are balanced, you cancel them. So it's 2 things. You balance the electrons, then you cancel. In this case, we have 2 electrons in the copper 2 plus and the zinc 2 plus, so we can cancel them. The 2 electrons. What is on the left, you write on the left. What is on the right, you write on the right. Please ensure that you do that. You cancel the electrons, you just copy. What is on the right, you write on the right. What is on the left, you write on the left. Then you are able to get your 3 marks, learners. Please do this as many times as you can. Calculate EMF already. When you start, you have to know that the anode, that one with the lesser standard reduction potential is your anode. The one with the higher standard reduction potential is your cathode. Now, for the EMF, make sure that for question 6.1.3, make sure that you are copying the formula as is given in the formula sheet. Please don't write your own formula. Use the one from the data sheet. Please just go and copy it. It's E cathode minus E anode. You know that the one with the bigger standard reduction potential is the cathode, which is positive 0.34 minus, don't forget we have minus from the formula and minus from the standard reduction potential, which is negative 0.76. So when you use your calculator correctly, minus and minus will be plus. That will give you 1.1 volts. So you are able to get your 4 marks. Please don't leave these marks. And then in this case, we are saying which one of the above reaction is spontaneous. So you will do that by simply referring as well to the EMF. It's able to tell you which one is that one. So we are saying now write down reaction A or reaction B. So in your choice, you are just choosing the reaction, and then after that you will refer to the standard reduction potential, but referring to the reducing ability in order to check which one is a better one. So that simplifies and brings about all that we were supposed to do this. So what I'm trying to say to yourself is that the table of standard reduction potential is crucial when you're dealing with galvanic cell. So ensure that as you deal with this kind of a cell, you are able now to go to the table, and as you use table 4B for galvanic cell, as I advise you now to say, copy the first one first, copy the second one, and then the one that is at the top, then you ensure that it's going to lose electrons. The one that is at the bottom, which it has a higher standard reduction potential, is going to gain electrons. So we reverse the one at the top for table 4B for galvanic cell. If you are using table 4A for electrolytic cell, you will do the same. The one at the top, which in this case will be chlorine, and then will lose electrons. Then you have the copper 2 plus that will gain electrons. So this was your paper, and I'm hoping that we were able to meet your standard, and you are happy now, and you are prepared, and you are looking forward to go and revise these papers and get as many marks as you can. You can see we're able to do this in 90 minutes. So thank you very much. Continue to prepare for your prelim examinations.